Welcome everyone. I'm pleased to be here to present my paper named A Proposed Framework to Implement AWP with Support of Blockchain. I'm sharing the list of the authors that were involved in this paper from Central Lille, from Concord Project Technologies, and from University of Qatar. Also, here is the plan of my presentation. And to start, we can say that from the literature, the construction sector it has a huge impact on the worldwide industry. But this sector is facing many challenges, mainly the cost overruns, the delays, the pervasive corruption, and the lack of transparency. And there are many methodologies and philosophies and aspects that were proposed as solutions to overcome these challenges. And one of these solutions is AWP, the Advanced Work Packages. But combining the methodology with the technology for data management in construction sector is very challenging. And for that, the blockchain offers many opportunities for decentralizations, mutability, transparency, and security of the data. And here is the idea of the paper for to make the exploration of synergetic potential between the AWP as a methodology and the blockchain as a technology to go forward in the growth of construction sector. In this paper, we'll be seeing the existing applications of construction project management using blockchain technology, the advanced work packaging applications as a methodology, and even if there is any transformational aspects that rely between the AWP and the blockchain technology. Let's start with present the advanced work packaging. It is a new methodology for managing complex projects, construction projects. It is dedicated to improve their performance. It is a construction-led project delivery process that adopts the following principle that the customer is a construction. In the AWP, the idea is going forward with construction with the end in mind. So our final customer is the construction guy in the field. So we are talking about the construction man and try to remove all the constraints that he is facing. And one of the main deliverables of the AWP is the path of construction. The path of construction is a logical sequencing of the construction work. It is an iterative, interactive process of deliverable. Here I'm presenting in the right the plot plan of the construction where the path of construction is drawn. And this path of construction is made in iterative phase from POC 1, POC 2, and POC 3 through iterative sessions, integrating all the stakeholders of the project. This methodology was implemented in different sectors, mainly the energy, the petrochemicals, the mining, the infrastructure. It has major advantages like zero accidents, in terms of safety, 10% reduction in cost implementation, and an increasing 25% in labor productivity. As a methodology, it has these performances, but the idea of challenging the data in project management is very important in our construction sector. And here there is a need to study and to search for traceability, security, and the integrity of the data to move forward with the best indicators in the construction project management. That's why the idea is to study and make the research about the blockchain applications and research in the construction sector. I'm sharing with you several papers that were interested in blockchain for construction project management. There are in smart contracts and real estates, in applications, in several applications in the construction. But when studying the literature, there is a need for future research in supply chain management, in BIM, and in contract management. And here we found the theoretical benefits of integrating blockchain with the AWT, because we found the gap in empirical research for the integration and real-world application. So this paper is proposing a framework to incorporate the blockchain technology into monitoring construction projects with the AWP methodology. As we are talking about blockchain, there are many technologies that are using. Here in this paper, we were interested in the Ethereum blockchain that is based on smart contracts platform. And here we were using the hybrid approach. It is a combining between the public blockchain and it is complemented by private ones. And we use the permissioned layers for sensitive information like the access, like the security of the data. And after that, we tried to find solution to integrate the AWP within this process. And on the on the right side, I am sharing the process that we will be using in this framework for an EPC contractor. EPC that stands for engineering, procurement, and construction. So first of all, we will be interested in the idea of receiving the project from the EPC contractor, and after that, we will move forward with the different aspects and the path of construction 1, 2, and 3. So the current scenario is based on a workflow. This workflow is heavily relies on manual emails and physical documents, and each document has its unique properties. The modeling process of this for workflow was based on BPMN 2.0 standards, and the analysis show that there is a significant data management challenges. And the idea here is to implement blockchain to digitize and streamline the process. The process, the digitalization of the process will be made on the four models that we were prepared, and there are in sequential order from receiving the project until the completion of the POC3. And the interest of the paper will be on this aspect in this study. So the case study present an actual digitalization actions where an ERP system was implemented. This implementation and tested is planned to be over 4 years, divided in 3 main steps. The first one is implementation and digitalization in the early stage, as I show you in the slide, in the previous slide. And after that, if this step was successful, we will move forward to the second stage where we will be interested in the 3 versions of the book. And if it is successful, the company will integrate all the framework in the all throughout the process. This study of this initial stage was made on a period of 12 months of development and integrating, and additional test period were added of 3 months. The successful execution of this phase will move forward to the implementation of the remaining 2 phases. The current phase analysis shown a total cost of investment of $80,000 for where the company can manage 40 projects, and there are 150 interaction in each project. This investment is based on mainly on a central server that is managing data sharing, email communication, notification, and there is involvement all multiple stakeholders. And by a calculation, we found that transaction cost of $2.66 per transaction using this methodology. And in our proposed framework, we propose this framework to be implemented on the blockchain based on four main aspects. First of one is a protocol based on the blockchain and developing it. After that, we were mapping the smart contract where we gave permissions of access, event logging, and project storage. After that, there is interactions between smart contracts in terms of developing the process from the beginning to the third steps of the POC. And after that, we developed the front end app to access and give the user to access to use the framework. All these aspects were studied based on the blockchain, and we found a transaction cost of $2.9 using the blockchain. So when comparing between the system using blockchain compared to traditional system or the system that was used by the company, we can the result is that blockchain have higher infrastructure costs due their hybrid architecture. There is the traditional system face difficult to quantify cost related to cyber attacks and data breaches. The cost-benefit trade-off depends on the application and security needs. The blockchain offers clear security advantages, including data provenance, transparency, immutability, and the blockchain facilitates use cases like supply chain tracking. And the most important thing is the choice between blockchain or traditional database depends on the specific use case and the security priorities within the organization. To conclude, the integration between blockchain and AWP could be as a solution for better construction management. There are next steps that need to be studied to include the validation of the framework, and there is a need in a deeper exploration, empirical validation. The future research is needed to refine the model and contribute the industry practices, and the goal is to leverage the blockchain potential for efficient construction management. Here are the references of the paper that were used, and thank you for your attention.